Hi, I'm Sid Parameshwaran, and I'm a fellow and tutor in physics at Hartford College.
My name is Patrick Roach, and I'm also a fellow and tutor in physics at Hartford College.
I'm Anoop. I'm a second year physics student at Hartford.
I'm Liz. I'm a second year physics and philosophy student at Hartford.
Awesome.
Okay, and today we're going to have a question and answer session.
Yeah, awesome. So basically, Liz and I are just two physics students that are just going to ask a few questions that you probably wouldn't have been able to ask at the open day. So I think I'm going to kick it off with this is a question for both of you. And it's, what are the key parts of the syllabus and what parts of the syllabus do you enjoy teaching the most? So if we start off with Sid.
So I often teach the second and third year courses. So I really enjoy teaching quantum mechanics because it's the first chance that students have to see that in the second year. And I also really like teaching statistical physics because it's quite close to things that I work on and research. And I enjoy, in both those subjects, bringing in ideas from my research into the course when I can.
And I generally teach first year physics and then optics or other courses in the second year, and also teach graduate lectures in the physics department on astrophysics. And I enjoy all of them. I think in the first year, special relativity is a very interesting topic and one which challenges people in a different way from the maths courses. So that's always interesting. Optics is the foundation of lots of experimental physics. And so I think we enjoy teaching all of the courses.
Good. What would you say college teaching's like?
So I really enjoy college teaching because of the fact that you're really teaching one-on-one with a pair of students or maybe three students at once. And it's really nice because you can really go deeply into problems rather than just sort of cover them at some high level. It's really fun to actually unpack some very detailed piece of a calculation that a student has struggled with. And very often students ask questions that you wouldn't normally get in a lecture because they've had time to sit and digest, struggle with the problem, and come in with some fairly deep questions. It can be really entertaining for the tutors. So hopefully the students enjoy it as well.
I would say the other advantage of small group teaching like we do here is that it gives us an opportunity to really understand when students have misunderstandings. So sometimes they don't quite get the point of a topic. And so being able to talk about it or around it, you can unearth problems that perhaps would have gone unnoticed otherwise.
Yeah, great. I'd agree. And how great the tutorial system is. So my next question is, when, as a student at Hartford, when will I meet students from other colleges within the physics environment? Should we go Sid first again?
Sure. Well, one obvious thing is you'll see students from other colleges in lectures because the lectures are with the entire cohort across the university. But also in some cases, you might have labs with some students from other colleges, although typically your lab partner will be from within your college. A lot of students really get involved in the Physics Society, which invites speakers from outside to give talks and things like that. Or when they do summer research, that happens in the department. And so you often get involved in a research group and you're working with people from other colleges. Particularly in the fourth year, your classes will take place in the university centrally because that's the year in which you specialize. And so that year you'll spend a lot of time with students from other colleges because it's quite possible that you'll be the only student in Hartford taking a particular option, but there'll be many students in other colleges, say doing astrophysics or doing particle physics. And so you'll have to interact with them rather than your college classmates when you're completing problem sets and trying to get to grips with the subject.
And of course, then there's a whole range of social activities where you tend to meet students from all over Oxford, including sports or drama or other activities that students are encouraged to participate in.
Sid mentioned labs briefly. Could you tell, Pat, could you tell us a little bit more about what labs are like?
Yeah, so one of the key things about physics, of course, is that it is an experimental subject. The only way we're able to tell whether our theories are correct is to test them. And so labs are an integral part of the physics course. It's very important that physicists understand both the limitations of experiment and the tools that you use to analyze and understand the significance of results. And so labs are a core part of the course, particularly in the first and second years, where you do typically 1 day a week for about 2 of the terms. In the first year, the experiments are relatively straightforward, but as you progress through the course, the experiments become both more interesting but also more demanding. And as I'm sure you're aware, one of the features of experimental science is that things don't always go to plan. And so I think it's also the case that doing experimental work can help build resilience. So all of these things are important. As you progress through the course, then you have opportunities or requirements to undertake projects, and some of those projects can also be experimentally based. And so you build on the skills that are developed in the early years, and that allows you to conduct really quite interesting projects in the final years of the course.
Awesome. So our next question is, and it's going to be for both of you, is what are you looking for in an application? And particularly, are there any extracurricular things that an applicant can do that boost their application?
You want to go ahead?
Yeah, okay.
Chime in.
So, what we're looking for in applicants is, first of all, motivation. Anyone who comes to study physics, they ought to be interested in the subject and have the motivation to work hard and continue for the 3 or 4 years that you'll be studying here. Physics, along with many of the science subjects, builds incrementally or successively on information that you accrue over time. And so it's important to have a very good basic foundation of mathematical techniques and an understanding of principles of physics when you start. And I would say the other thing is a curiosity. Curiosity is the thing that drives research in particular and drives interest in really probing into a subject. Being able to communicate and articulate concerns is something you need to develop as part of the tutorial approach to learning. And so those are, I would say, the key things that we're looking for in students is motivation, core ability, potential, and curiosity. And then in terms of what you might want to write down in your application, I think things that support those qualities are what I would recommend. And one thing that I would like to mention is that we know that in some schools, the personal statement is written by the student. In other schools, it's written by a committee, which may have involved input from the student at one point. And so we don't put a great deal of weight on the personal statement.
I think Pat summed it up really well. I don't think I have too much to add to that. Yeah. But the curiosity is really an important thing. I think that's what keeps people going through 4 years of a degree. And so if we can detect that curiosity, that really is something that we're really looking for.
Great. So after our application to the interview process, what sort of things might you ask in an interview?
Well, we could ask a range of subjects. Some of them may well be things that you've come across already at school, but some of the questions we ask may be unfamiliar. Again, I'd like to clarify one thing, and that's that you hear rumours that Oxford interviews use trick questions to trap the unwary students, and we don't do that because it's not in any of our interests. We may ask questions that are unfamiliar, but that's because we're not looking to test what you remember. We're looking to test what you know and how you go about solving things that you don't know. And so that's really the essence of the interview. It's probing your ability to respond to a question that's posed.
I think it's really important to have a sense of what the interview is for. It's partly for us to understand what you know, but it's also very, very important for us to get a sense that you'd be comfortable in the tutorial saying that you don't understand things and asking for clarification. And there's a back and forth that goes on in a tutorial, and the interview is supposed to be a sort of half-hour version of that to some extent. So we want to see if people are going to be good participants in a tutorial and interact with us in a way that we can exchange information. It may well be that there are very, very talented students in physics, but they're not quite suited to the course and the way teaching is done at Oxford. And partly the interview is to work through that and see that you would enjoy the tutorial system and that wouldn't be a chore for you. And very often, I think the best interviews I've had have been with the students who've had not been able to answer the problems immediately, but the fact that they would take hints when they were suggested and really go very far with it, even though maybe they didn't know the answers to start with. I think it's really important that the interview is what you make of it. And it's really, as Pat said, we're not trying to trick you. We're just trying to find out how well you'd fit in with the whole style of teaching here. And I think it's really something that we're willing to adapt to the situation. And so the idea is that we like to make you as comfortable as possible within the context of an interview.
Right. And on the topic of interviews, let's just say that a student has been asked about a topic they've never heard about before or know very little about. What would you expect them to respond with? And or what would be the best way that you'd want a candidate to respond?
I think, to be honest, if they've never heard about it, they can say, that's not something I know about. Can you clarify or can you explain to me what that is? And very often we're very happy to do that because we realize that not everybody comes with the same background. It'd be a very boring place if everybody had exactly the same understanding of everything. So we're very happy when students are honest. I think the thing that you shouldn't do in that is to pretend that you know something that you don't, because then you're not setting yourself up to do well in the interview.
Mm-hmm. The other thing I would say is that in an interview, what we're looking for are students who are willing to engage with problems. So even if you don't know what it is, then with a bit of clarity, a bit of prompting, you may find that you know how to tackle the problem, even if it isn't something you've seen before, using the skills and knowledge that you've developed in your schoolwork.
Next question is a little bit less serious. Does it matter what I wear to an interview?
No, you should just try and be comfortable as much as you can. You shouldn't feel like you have to dress up for us, but you want to be sure that you're comfortable and relaxed, and you're not, that you can think your best in what you're wearing.
And this is the last question on interviews. So let's just say I'm a student that was wearing that they hadn't studied A-level chemistry because they didn't know they wanted to go into the sciences when they were applying for their A-levels. How would this affect their application?
Well, actually this is a good opportunity to clarify that the course at Oxford is a physics course. And that sounds like a strange thing to say, but it's because at other universities, there are courses in natural sciences or physics with computing or with electronics or something like that. But what we offer is a physics course and a physics and a philosophy course. And so whilst doing more science is generally beneficial because you learn a sort of broader range of topics and you get a broader understanding of the whole edifice of science, in the end, what matters here is what you know and what you learn about physics. So to be specific about chemistry, there are aspects of the course where a bit of knowledge of chemistry helps, and that tends to come into things like specific heats and Avogadro's number, and also in areas like the atomic structure and the different orbitals and the nomenclature. But those are really very small components of a large physics course. So I would say that there is no disadvantage in reality in not having studied chemistry.
The next question is, how well is it to do? How important is it, sorry, to do well in the physics aptitude test?
Yeah, I'll take this. So it's really important to do well in the physics aptitude test. We get, in the physics department, we offer about 200 places a year to study physics or physics and philosophy. And we get of the order of 1,600 applications. So we have an over subscription rate of roughly 8 to 1, or at least have had in recent years. And we can't interview anything like that number of people. So we have to make a selection. And so one of the key criteria that we use in selecting people for interview is the performance in the physics aptitude test. Now, it's not an absolute criterion because there are other circumstances and there's contextual information and things which is also taken into account. But essentially what it means is that if you do well in the physics aptitude test, you're much more likely to be shortlisted and then summoned for an interview. If you don't do well in the physics aptitude test, we would really have to find a compelling reason why you should be offered an interview slot rather than someone who's scored at a much higher level and on the face of it looks like they have a much better state of preparation to do well in the course. So my advice is take the aptitude test really seriously. Look on the website, there are past papers, there are illustrations of the content and the time available. And so prepare for it as well as you can and aim to do as well as you can. And that gives you the best chance to be considered for a place to study here.
Awesome. So now moving away from applications and just looking at the course in general, when I look on the physics website, it says that there are some short course options offered. So we're just wondering what kind of examples are popular amongst students, or what options are there?
So there's a long list, so I don't think we can go through all of them, but there's some that are particularly popular. I think astrophysics is perennially quite popular because a lot of students come in with an interest in astronomy and astrophysics, and so that's a very popular short option. Quantum ideas is popular because it's a short option that comes in the first year, and you don't see much quantum mechanics in the first year, so some students are quite eager. That's something that drew them into physics, so they often want to do that, and so they get pulled into that. Students who are more mathematically minded often want to take some of the more mathematical short options or explore a course in the maths department, which can be done sometimes. So there's a physics course on complex variables that's often a popular short option among the students who come in with more maths preparation and want to explore that a little bit further. Some students also, especially those who have a hankering for travel, sometimes take a language option, and there are cases where students have also done things like history of physics and things like this. So I've just given you a few examples because there's such a range of these options, and so I think it's really a chance for students to. I think we recommend that students really explore those options because that helps them make up their minds about a specialization in their fourth year of the course, where they may not, often the fourth year, they may not have had a taste of some of those subjects without going through one of the short options because they're not directly in the curriculum under those names. I don't know if you have anything to add.
I would absolutely agree with that. And, there are topics in physics that probably people, when they apply, have no idea even exist. And so, for example, biophysics is quite likely something that you've never come across whilst studying physics at school. is a discipline that's becoming increasingly important. And so you can sample that, for example, as one of the short options, or things like climate physics. And physics touches so many areas, and we try to give a taste of that through the short options.
Brilliant. So one last question, and that's what makes Hertford special? And in addition to that, what's the Tanner Society?
So I think one thing that is really great about Hartford is it's a very friendly place. So, when I came into Hartford as a tutor, I found that the students were really friendly and supportive, both of each other and of their tutors. And I think that it's a place that's very non-judgmental, but, holds people to high academic standards, but in a way that is very supportive. And we try to keep that environment going. I also think that, maybe unusually among some of the other colleges, we have a large breadth of experience across our tutors. So I'm a theoretical physicist working on the properties of materials and on statistical physics. Pat is an astrophysicist, and our colleague Sam Henry, a lecturer at Hartford, is a particle physicist. So I think we, span 3 of the 6 sub-departments in the physics department, and we have friends and colleagues in some of the others. And so between us, I think we understand a large range of the curriculum. So I think when our students look for things like career guidance or are thinking about doing research and going further in their studies, I think they have people they can come and talk to about that. And I think that's pretty special. And not all colleges have such a wide range of expertise. And Pat, maybe you want to tell us a bit about the Tanner Society.
Yeah, we've taken a view that one of the things we can do is help foster connections between the different years. So, when people come here, colleges operate a kind of what sounds a very strange system, a college parentage thing, where people are put in touch with people who are with students who are already here and have been through what the incoming students are about to go through. So that, I think, is really good. But we also encourage students across all 4 years of the physics course to keep in touch, so they can talk to each other, find out, particularly in terms of academic topics, which resources they found to be most useful, which books most helpful, any of those kind of things. But also because we think it's important socially, and we can talk about, what difficulties people are having, or what topics they find exciting, and so forth. And so we have a physics society which is called the Tanner Society. It's named after my immediate predecessor, who was called Neil Tanner. And amongst his lasting legacies are he was instrumental in opening up Oxford to applications beyond the narrow set of private schools that traditionally sent students to study here before the 1960s. And so we wanted to keep that memory going, but also to build on his, I think it's fair to say, slightly idiosyncratic approach to tutorial teaching. And so we have termly dinners, and we encourage students to mingle and to get to know their tutors in a social and hopefully not at all threatening environment, so that people are relaxed and they can just talk as human beings.
Well, that was all the questions that we had for you guys. And thank you for answering our questions.
Thank you.
Thank you. It's been great talking with you.
Welcome to Hartford College. My name is Sid Parameshwaran, and I'm a fellow and tutor in physics at Hartford. I'm also an associate professor in theoretical physics, where I lead a research group that focuses on the low temperature properties of quantum materials and their links to quantum computing and quantum information.
Hello, my name's Patrick Roach. I'm one of the physics tutors at Hartford College, and I'm a professor of physics, and my research area is in astrophysics. So I've been at Hartford College now for more than 20 years, and I must say I feel very fortunate to be here. It's a great place to work, and I have really excellent colleagues, very interesting people work here with a large range of disciplines, and of course we have really excellent students, and so the interactions are just one of the best things about being here. My research area is in observational astronomy, and I'm particularly interested in interstellar matter, cosmic dust, what it's made of, how it evolves, because it plays a really important role in lots of aspects of interstellar physics, but also, of course, is key to the formation of planets and eventually to the formation of life. I've spent a lot of time working with the world's best astronomical observatories and feel very fortunate to have worked with really outstanding scientists across different continents, in Chile, in the United States, in Australia, and in Europe. Astronomy is a very fast-changing field, and we're continually updating and upgrading the facilities that we have as new technologies become available. And I find that really exciting. So as part of my research, I've been fortunate to spend time at these observatories and to participate in some of the major projects that are being developed, including the development of astronomical instruments, specifically infrared instruments that have been built partly in the laboratories here in the Department of Physics at Oxford, and are now in collecting data at some of the world's leading observatories.
Hello, I'm Sam Henry. I'm one of the physics tutors at Hertford College. I'm also a particle physicist. I work on the instrumentation for the planned upgrade of the ATLAS detector at CERN. We're building a detector to probe the collisions of high-energy proton beams at the Large Hadron Collider, and we have to keep up with the higher flux of particles that we'll get with the next upgrade. In Hertford College, I tutor the maths side of the first-year course, doing one tutorial a week where we cover topics including calculus, complex numbers, vectors and matrices, differential equations, then moving on to vector calculus and wave motion. Maths is an essential skill for physicists. The aim of the course is to give you the maths skills that you'll need in order to study the advanced physics topics that you'll cover in later years.